In this figure, we have a parallelogram ABCD, and you have to tell the values of the variable x and y. So since ABCD is a parallelogram, then AB, side AB, is equal to side CD or DC, right? Because in a parallelogram, the opposite sides are equal and parallel, and side AD is equal to side BC. Now from here, this AB is what? 26. The measure of side AB is 26, and this is 3y minus 1. So if you solve it, you get 3y is equal to 26 plus 1 means 27, and this gives you y is equal to 9. It's all in centimeters, so the length has to be in centimeters, or the measure in centimeters. So this is 9 centimeters. And similarly here, this is 3x equal to 18, and if you solve it, you get x is equal to 6. Again, it has to be in centimeter. I forgot to mention it here, that's why I've written. So x is equal to 6 centimeter and y is equal to 9 centimeter. Again, ABCD is a parallelogram, and you have to tell the values of x and the variable y. Now, the property that we will use here is the diagonals of a parallelogram bisect each other. That is, the diagonals divide each other into two equal halves. So if you take this intersection point as O, let this be point O. You can clearly see that this point O will actually bisect these two diagonals. Therefore, AO is equal to CO, right? Diagonals, this diagonal's midpoint is O, so AO is equal to CO. What's AO? AO is 20, and again this has to be in centimeter, so AO is 20 centimeter, and this is y plus 7. From here you get y is equal to 20 minus 7, that is 13 centimeter. And if you solve for this diagonal BD, BO is equal to DO, so x plus y is equal to 16. From here, x plus y is how much? 13 centimeter, and this is equal to 16 centimeter, and this gives you x is equal to 3 centimeter. ABCD is a parallelogram and EFGH is a parallelogram. So A, B, C, D is a parallelogram, and E, F, G, H is another parallelogram. You have to tell the value of x. Now in the parallelogram ABCD, we can see that if we take, this is AB and this is BC, so A, B, D and C, this one will be its transversal. Two parallel lines, it's transversal, and these two angles are what? Internal angles on the same side of the transversal, and we know that the internal angles on the same side of the transversal are supplementary. That is, if you add them, you get 180 degrees, right? So if from this property of the same internal angles on the same side of the transversal, (120°), and if we assume that this is angle D, so if this is angle D, angle A is what? 120 degrees plus angle D has to be equal to 180 degrees from this property. From here you get angle D is equal to 60 degrees. If angle D is equal to 60 degrees, now in a parallelogram the opposite angles are equal. So ABCD, what is the opposite angle to angle D? Clearly angle B. So angle B will be what? Angle B will be 60 degree. So angle B is also equal to 60 degree. Now in the parallelogram EFGH, if you look at this angle G, that is this one, and angle E, that is this one, these are the two opposite angles. Therefore angle E will be equal to angle G, that is equal to 70 degrees. So now we have the value of E, we have the value of angle B. Can't we find the value of X? Because if we suppose that this is the point of intersection and let this be O, then in triangle EOB, angle E plus angle O plus angle B is equal to 180 degrees, right? Now if we know the values of E, that is 70 degrees, what's angle O? That is X. What's angle B? That is 60 degrees, and this is equal to 180 degrees. So from here X is equal to 180 degrees minus 130 degrees. 76 plus 60 is 130. So this is 50 degrees. Is ABCD a trapezium? Explain why. So ABCD is a quadrilateral and you have to tell whether it is trapezium or not. In a trapezium, we have one pair of sides which are parallel, and we have another pair which is non-parallel. If you look at these two lines AB and CD, so and this angle B and C, and let me explain you in this way. So let's say that these two are lines, right, and this is the transversal of these two lines, that is, this is line L, this is line M, and let this be line N. So since this is a transversal, this angle and this angle is one pair of internal angles on the same side of the transversal, and this angle is another pair of internal angles on the same side of the transversal. If we add this angle, and this angle, right, or if we add this angle and this angle, if you get the sum as of these two angles or of these two angles you get the sum as 180 degrees, it means that these two lines are parallel, right? We have discussed this here. So if the two lines are parallel, then the internal angles on the same side of the transversal, that is, if these two lines are parallel, then this angle plus this angle has to be equal to 180 degrees. Same thing, this angle plus this angle has to be equal to 180 degrees. So here if you add this B and C, you get what? 180 degrees. It means that if B and C, these two are internal angles on the same side of the transversal, that is BC, then surely we are getting 180 degree on adding them up, that is AB is parallel to side AB is parallel to side CD, right? This is parallel. That's why we can say that yes, this is actually a trapezium, because it's very clear that these two lines are non-parallel. So we have one pair that is non-parallel and we have another pair that is parallel. That makes it a trapezium. Here BC is parallel to AD, what is x and what is y. Now angle B is given is equal to 130 degree, and this mark tells you that it's actually at a right angle, that is, this is 90 degrees. If this is 90 degrees, so tell me, if I take this AD, that is parallel to this one, BC, right? And this one is the transversal for these two parallel lines. So tell me, just now we have discussed here this thing, this angle plus this angle has to be equal to 180 degrees. Two lines, parallel lines, and it's transversal, internal angles on the same side of the transversal. So angle C plus angle Y is equal to 180 degrees. So from here you get Y is equal to 90 degrees. You get Y as 90 degrees. So this is also 90 degrees. Now since this is a what? This is a quadrilateral. The sum of the internal angles of a quadrilateral is equal to 360 degrees. We know this. So from here, 90 degrees plus 90 degrees plus 130 degrees plus x is equal to 360 degrees. 90 plus 90 is 180 plus 30 is 310. So 310 degrees plus x is equal to 360 degrees. From here you get x as 50 degrees.